For number 1, we're going to graph this parabola and also list the vertex and intercepts. I'm going to start by writing it in standard form, and you can read about parabolas on page 612 in the textbook. Section 6.1 is called parabolas. I want to start by writing this in standard form and then completing the square to do that. So I'm going to minus 6 from both sides. That gets me to here. And now I want to complete the square. So take the number in front of y, divide by 2, and then square that answer. So 4 divided by 2 is 2. Square that, you get 4. And so I'm going to add a 4 here on the right side. I'm also going to subtract a 4. I do that so that the total I'm adding is 0. This is an equal statement, and I can't just add a number or it would ruin the inequality. But you can always add 0 because that changes nothing. So by adding 4 and subtracting 4, I really haven't changed anything on this right side. But what I have done is now I can group these 3 numbers together and write it as a perfect square. I have the minus 4 left out here. Add that to both sides, and you get to here. So now we're in standard form, and you can just look at it and see what the vertex is. It's going to be 2 for the x coordinate and negative 2 for the y coordinate. So that's our vertex. The number multiplied in front of our perfect squared term here, we need to see if it's positive or negative. And there's nothing written there because it's just a positive 1, and we don't write when we multiply by a positive 1, we just don't write it. So we have a positive 1 here. And since it's positive, we know that means the parabola opens to the right. So this is really going to help us get the graph. A vertex of 2, negative 2 opening to the right is going to be C. If it would have been a negative number, the parabola would open to the left. Now for the intercepts, x-intercept, plug a 0 in for y, and when you solve that out, you get the x equals 6. So 6, 0 is our x-intercept. We saw that on our graph here. For y-intercept, plug in a 0 for x, and you get to here, and whenever you square a number, it's always positive. So there's no way to square this right side and get a negative result. There's no way this can be equal. This is a false statement right here. And so since this is not a true statement, we know that plugging a 0 in for x doesn't work, or in other words, there is no y-intercept. For number 2, we're identifying what type of graph this is. I'm looking at page 643, which is in section 6.4 as the summary of conic sections. So I'm going to start by writing this in just standard form where everything is on the left and we have a 0 on the right. So I did that down here. And then there's a great chart on page 643 where you can go through and see what type of graph it is. So it's not a parabola because either a or c would have to equal 0. A is the number in front of x squared, which is 1/6 for this problem, and c is the number in front of y squared, which is negative 1/4. It's not a circle because a and c would have to be equal. It's not an ellipse because a times c would have to be positive. It's a hyperbola because a times c is negative. And also, since the x squared is positive, since a is positive, and y squared is negative, we know it opens left and right as opposed to up and down. Number 3, to graph this conic section, I'm again going to go through the chart on page 643 to get an idea of what conic section it is. The number in front of x squared would be 25. The number in front of y squared would be 9. So it's not a parabola because a and c, neither one of them 0. It's not a circle because a doesn't equal c. It's not it is an ellipse because when we multiply them together, we get a result greater than 0. So we have an ellipse here. And to write it, if you go to the section on the ellipse, the easiest way to graph is to make the right side of the equation equal to 1. This is discussed on page 623 in the section on ellipses, which is 6.2. And so I'm going to get it in this form just by dividing both sides by 225. So divide everything by 225, you get here. We're in standard form now. You can quickly identify the center. It's 3, 4. It's gonna be longer up and down because the bigger number here is underneath y. And to figure out how long that axis is, you take the square root of this value, which gives you 5, and double it to 10. And the smaller horizontal axis is going to be the square root of this is 3, double it to 6, so it has a length of 6. So now we have enough information to graph this. We go to the center. We said the major axis had a length of 10, so that's up 5, down 5, that gives you a length of 10, mark those points. Length of 6, go left 3 and right 3, and now you can connect those dots and draw your ellipse.